Around 6 to 7 million years ago, early hominins like Sahelanthropus and Orrorin split from the chimpanzee lineage. By 554 million years ago, species such as Ardipithecus were already walking upright. Between 4–2 million years ago, gracile and robust Australopithecines thrived in Africa. 300,000–200,000 years ago, anatomically modern Homo sapiens appeared in Africa. Starting about 3.3 million years ago, early ancestors knocked rocks together to make simple stone tools. Fast forward to the late 1700s, James Watt's steam engine upgrades kicked off the Industrial Revolution and changed everything. Our journey beyond Earth to other planets and galaxies will start from our home planet Earth. The name of Earth was originated in Old English and Germanic, which simply means the ground. Earth is the only planet in the solar system with liquid water on the surface. Vast oceans on Earth provided a convenient place for life to begin about 3.8 billion years ago. Earth is the 5th largest planet in our solar system, having average radius of 3959 miles, equatorial diameter of 7926 miles, circumference of 24,901 miles at the equator, distance of 24,860 miles from pole to pole. Earth's axis is tilted about 23.4 relative to its orbital plane around the Sun, causing seasonal changes. As Earth orbits, one hemisphere receives more direct sunlight and longer days resulting in summer, while the other gets less direct rays and shorter days, leading to winter. Around the equinoxes, the tilt aligns so both hemispheres get nearly equal sunlight, marking spring and autumn. Based on chemical component, Earth can be divided into 4 layers: inner core, outer core, mantle, and the crust. At its heart lies the inner core, a solid sphere of iron and nickel, roughly 1,221 kilometers, 759 miles in radius. Despite scorching temperatures near 5,200 C, comparable to the Sun's surface, it remains solid. Immense pressures, 3.6 million atmospheres deep within the planet. Surrounding it is the outer core, a fluid layer about 22–60 kilo thick, made of molten iron-nickel alloy. This churning metallic ocean generates Earth's magnetic field and sees temperatures between roughly 3,004 C decreasing outward. Above that floats the mantle, Earth's thickest layer, about 2,900 kilometer, 1,800 meter deep, comprising hot, solid silicate rock so ductile it behaves like caramel over geologic time. This sluggish flow drives tectonic plate movement, contributing to volcanism and planet recycling. Finally, at the surface is the crust, a thin outer skin ranging from 5–10 kilometers under oceans to 20–70 kilometers beneath continents, averaging around 30 kilometers. It's the rigid layer we live on, broken into tectonic plates sliding above the mantle. Earth's surface features, including volcanoes, mountains, and valleys, are shaped by movements in the lithosphere, the rigid outer layer made up of the crust and upper mantle, which is broken into large, constantly shifting tectonic plates. These plates drift at a rate of a few centimeters per year, about the same speed your fingernails grow. Take the North American plate. For example, it's slowly sliding westward over the Pacific at roughly 23 centimeters per year. When plates grind past each other, transform boundaries, collide convergent, or pull apart divergent, they cause geological drama: earthquakes, volcanoes, trench formation, and mountain building. About 70% of Earth's surface is covered by ocean, and those waters average roughly 4 kilometers deep. Almost all of Earth's volcanoes lie hidden under those oceans, which also hide the longest mountain range on the planet, a massive underwater ridge stretching across the Arctic and Atlantic that's 4 times longer than the Andes, Rockies and Himalayas combined. Even Mauna Kea in Hawaii, while only 4,205 meters above sea level, actually measures over 10 kilometers from its underwater base to its peak, making it taller than Mount Everest when measured that way. Earth's atmosphere, a thin layer of air hugging the surface, contains about 78% nitrogen, 21% oxygen, and around 1% other gases like argon. Carbon dioxide, neon, and trace amounts of water vapor and methane. Earth's atmosphere is our life support shield. It regulates climate and weather, blocks much of the sun's harmful ultraviolet radiation, and protects us from space debris. The stratospheric ozone layer in particular absorbs most UVB and nearly all UVC rays, safeguarding living tissue and ecosystems. Additionally, when tiny meteoroids hurtle into our atmosphere at high speeds, friction burns them up into glowing shooting stars, so only the rare, larger chunks ever reach the ground. Earth's rapid rotation and its molten iron-nickel core generate a powerful magnetic field, which is stretched into a teardrop shape by the solar wind, a continuous stream of charged particles flowing from the sun. When some of these particles get trapped by the magnetic field near Earth's poles, they collide with gases in the upper atmosphere. These collisions make the gases glow, creating the breathtaking auroras, the northern and southern lights. This magnetic field also guides compass needles. Making them point toward the magnetic North Pole. But Earth's magnetic polarity isn't fixed. It has flipped many times in the past. Geological records show that a magnetic reversal occurs roughly every 400,000 years on average, though not on a regular schedule. Such reversals don't appear to harm life, and another one is unlikely for at least 1,000 years. When it does happen, compasses could behave erratically for centuries, and once the switch is complete, they'll point south instead of north. So that's our incredible home planet Earth, alive, dynamic, and full of surprises. Thank you for exploring it with me. Don't forget to like, subscribe, and stay curious about our home planet.